This lecture is about solar thermal electric systems. We know that electrical energy can be obtained from solar energy by using two different methods. In the first method, the thermal energy of solar radiation is utilized and it is then converted into electrical energy. And in the second method, the solar energy can be directly converted to electrical energy by using photovoltaic panels. So here we are going to discuss the first method, that is the solar thermal electric systems. Systems that utilizes thermal energy of solar radiation to produce electrical energy. So solar thermal electrical systems are the systems which convert solar energy into electrical energy by utilizing the thermal energy of the solar radiation. So first of all, the thermal energy of the solar radiation will be extracted, and this thermal energy can then be converted to mechanical energy or electrical energy. So thermal energy of solar radiation can be used for producing steam. Using this temperature, thermal energy, water can be converted to steam, and this steam can be used for driving turbines coupled to generators. So either mechanical energy or electrical energy can be obtained as required. So now let us move on to the classification of solar thermal electric systems. So they are mainly classified into three types: low temperature cycle, medium temperature cycle and high temperature cycle. Low temperature cycle includes systems whose temperature that does not exceeds 100 degrees Celsius. They will have a maximum temperature of 100 degrees Celsius, and example of such system is the solar flat plate collector. The second one is the medium temperature cycle. These are the systems in which the temperature ranges between 150 degrees Celsius to 300 degrees Celsius, and example is parabolic trough collector. So next one is high temperature cycle. So temperature available will be high, it will be more than 300 degrees Celsius, and it uses a concentrating collector like the central tower receiver collector. So now let us see each of these systems in detail. So first, the low temperature system. So low temperature system, as the name indicates, the temperature available from these systems will be limited. It is in the range 60 to 100 degrees Celsius. So we know that the boiling point of water is 100 degrees Celsius, and the temperature required to convert water into steam is more than 100 degrees Celsius. So using this temperature, we cannot produce steam. So if we have to drive a steam turbine, we need steam. So in low temperature system, as the temperature range is low, we cannot convert water into steam. So we have to use some other organic fluid as the working fluid in such systems. So if we are using some organic fluids having a low boiling point, they can be converted to steam using this particular temperature, and this steam can be used for driving turbines and producing electrical energy. So low boiling point organic fluid should be used as the working fluid in low temperature systems, and they have collection efficiencies about 30 to 50%. They can convert around 30 to 50% of collected solar energy into electrical energy. That is collection efficiency. Okay, now, so they can be used for driving turbines, and the energy generated is sufficient for lighting a group of houses, or that energy, mechanical energy from the turbine can be used for irrigation purposes. So we will see it in the coming slides. Okay, so now there are two types of low temperature systems. One is solar pond and another one is solar flat plate collector. So this is a low temperature system, the solar pond. Solar pond is a pond that receives solar radiation and which contains salty water. So solar pond usually contains salty water. So we can call it as brine solution. So we know Brine solution means a solution of NaCl. So in chemistry we will call a sodium chloride solution as a brine solution. So this water in the solar pond will be salty. So this can be called as brine solution. So when this solar pond receives solar radiation, the water brine solution gets heated, and this hot brine is then taken into the evaporator boiler. So in this evaporator boiler, this hot brine solution exchanges its heat with the organic working fluid. ഞാൻ നേരത്തെ പറഞ്ഞായിരുന്നു നമുക്ക് ലോ ബോയിലിംഗ് പോയിന്റ് ഉള്ള ഒരു ഓർഗാനിക് ഫ്ലൂയിഡ് വേണം ഇവിടെ വർക്കിംഗ് ഫ്ലൂയിഡ് ആയിട്ട് യൂസ് ചെയ്യാൻ. സോ ഇൻ ദിസ് ഇവാപ്പറേറ്റർ ബോയിലർ, ദിസ് ഇസ് ഓൾസോ നോൺ ആസ് ഹീറ്റ് എക്സ്ചേഞ്ചർ. ഹിയർ an exchange of heat occurs between the hot brine solution and the organic working fluid. So the organic working fluid takes away the heat from the brine solution and it will be converted to vapor. The organic working fluid vaporizes by consuming the temperature from the hot brine solution. Okay, so the brine solution, after exchanging its heat with the working fluid, becomes cold, and that cold solution is again given back to the solar pond. Okay, then the vaporized working fluid, the vapor of the organic working fluid is then used for driving the turbine. The turbine will be coupled to a generator which generates electrical energy. So the vapor of the organic fluid after driving this turbine is collected on a condenser. It is fed to a condenser where it is condensed, condensed, and it becomes the fluid state. It becomes the organic working fluid again, and it is then pumped to the evaporator boiler, heat exchanger. Okay, so how can we condense this vapor here in the condenser? How is the hot vapor of the organic fluid is condensed? This is done by pumping cold water from a cooling tower. So a cooling tower supplies cold water to this condenser. This cold water takes away the heat from the vapor of the organic working fluid. Then after taking the heat away, the water becomes hot and it is then again circulated through the cooling tower. Okay, this is the basic working of a solar pond. So steam, the vapor after driving the turbine is taken into a condenser where it is condensed back to its original state and it is given to the evaporator boiler. So that is all about a solar pond. Now let us see the other low temperature system, that is the low temperature flat plate collector. So we know a flat plate collector. So this low temperature system uses an array of flat plate collectors. A number of flat plate collectors connected in series is used, which collects solar radiation, which is exposed to solar radiation. So we know that in flat plate collectors, the tubes carrying the working fluid are in contact with the absorber of the array, absorber of the flat plate collector. So when the absorber receives solar radiation, it gets heated and it will transfer the heat to the heat transfer fluid. നമുക്കറിയാം ഫ്ലാറ്റ് പ്ലേറ്റ് കളക്ടറിൻ്റെ അബ്സോർബറുമായിട്ട് കോണ്ടാക്റ്റിലിരിക്കുവാണ് heat transfer fluidine carry ചെയ്യുന്ന tubes. So when the absorber is getting heated, the heat transfer fluid, that is usually water in the tube, also gets heated. So that hot water is then taken out and it is fed to the butane boiler. The butane boiler. So here this boiler is also known as heat exchanger, where this hot water exchanges its heat with butane. So here butane is used as the organic working fluid. So when water exchanges its heat with butane, butane is converted to vapor and water loses its temperature, becomes cold, and it is then again fed to the tubes. Okay, So the butane vapor formed here is then fed to a butane boiler. So it drives the boiler, it is fed to a butane turbine, not a boiler. The vapor, butane vapor is fed to a butane turbine. So it drives the butane turbine. The turbine will be coupled to a pump. So when the turbine operates, this pump also operates, which helps to lift water from a well, which can be used for irrigation purposes. Okay. Now this butane vapor, after driving the turbine, is fed to a condenser where it is cooled. In the condenser, butane vapor is cooled and it is converted to its liquid state back, and again it is fed to the butane boiler using a butane pump. Condensed butane liquid is fed to the butane boiler using this butane pump. Now, the condenser cools the butane vapor by taking cold water from this well itself. So this water pump lifts water from this well. That water itself can be used for cooling the butane vapor, and the water after cooling the butane vapor can be used for irrigation purposes. So this is the working of a low temperature flat plate collector. So now let us move on to the medium temperature system. That is, example is parabolic trough collector. So we know the operating temperature of medium temperature systems is in the range 150 degrees Celsius to 300 degrees Celsius. So the example, in order to get such a temperature, we need to use some of the concentrating collectors, and we use parabolic trough collector here. So we know, we have already studied the parabolic trough collector. In case of a parabolic trough collector, the reflector is in the form of a trough with parabolic cross section. So the reflector, or the portion that collects solar radiation, is in the form of a parabolic shaped vessel. Okay. This is made up of mirror segments. Number of parabolic shaped mirror segments are used for producing this reflector. And when solar energy falls on this reflector, entire light will be concentrated to the focal line of this parabola, and the pipes carrying the heat transfer fluid will be placed along the focal line, and that pipe carrying the heat transfer fluid will be coated with a suitable absorber. So ഇവിടെ സെപ്പറേറ്റ് ഒരു അബ്സോർബർ ഇല്ല. നമ്മുടെ ഹീറ്റ് ട്രാൻസ്ഫർ ഫ്ലൂയിഡിനെ ക്യാരി ചെയ്യുന്ന പൈപ്പിനെ തന്നെ നമ്മൾ അബ്സോർബർ ആയിട്ട് യൂസ് ചെയ്യുന്നു. It will be coated with a suitable material to act as the absorber, and that absorber tube is placed inside a glass envelope. So this is that glass envelope. Okay. So we know this is a type of concentrating collector, and it receives direct radiation only. So in order to get direct solar radiation, this device should always be oriented along the sun's direction. So it needs some sun tracking mechanism. So it is done with the help of this chain drive and jack shaft arrangement. So this arrangement helps to move or orient the parabolic trough collector along the sun. So now let us move on to the high temperature system. So high temperature systems have very high temperatures in the range about more than 300 degrees Celsius. So it should use the concentrating collector, the high temperature concentrating collector, that is the central tower receiver collector. So this is a central tower receiver power plant schematic diagram. So let us see how a central tower receiver collector power plant works. So there will be a receiver, there will be a tower located at the center of the plant, and on top of the tower there will be the receiver, and around this tower on the ground there will be a number of flat mirrors known as heliostats will be arranged. So ടവറിന് ചുറ്റും ഹീലിയോസ്റ്റാറ്റ്സ് എന്ന് പറയുന്ന ഫ്ലാറ്റ് മിറേഴ്സ് അറേഞ്ച് ചെയ്തിട്ടുണ്ടായിരിക്കും, and they are oriented in such a way that entire light falling on them will be focused onto this receiver. So thousands of such mirrors will be used for concentrating light onto this receiver. So the receiver will be heated to a very high temperature, and there are pipes carrying the heat transfer fluid into and out of the receiver. So here there are different materials that we can use for transferring this heat, for carrying away the heat from this receiver. In this particular system, sodium is used as the heat transfer fluid. Okay, so cold sodium from a storage tank is fed to the receiver through the pipes, and it will get heated, and that hot sodium is taken out. It can be stored in a tank, and whenever it is required, that hot sodium can be fed to a heat exchanger, where this hot sodium exchanges its heat with water. So ഇതൊരു ഹീറ്റ് എക്സ്ചേഞ്ചർ ആണ്. ഹോട്ട് സോഡിയം നമ്മൾ ഈ ഹീറ്റ് എക്സ്ചേഞ്ചറിലേക്ക് ഫീഡ് ചെയ്യും. അവിടെ വെച്ച് കോൾഡ് വാട്ടറുമായിട്ട് ഈ ഹോട്ട് സോഡിയം അതിൻ്റെ ഹീറ്റിനെ എക്സ്ചേഞ്ച് ചെയ്യും. Then water will be converted to steam, and that superheated steam will be given to a turbine. So it will drive the steam turbine, which is coupled to a generator. Generator generates electrical energy, and the steam after driving the turbine is fed to a condenser for cooling. So steam will be converted back to water, and this water is then again circulated to the heat exchanger. So the hot sodium, after exchanging its heat with water, will become cold, and it can be stored in this cold storage tank and again be circulated to the receiver for carrying away the heat. So this is the working principle of a central tower receiver power plant.